In this video, we'll explain the science of TV. Welcome back to Explaining Difficult Stuff. Our nerds are dedicated to helping people of all ages understand complicated topics. If you're curious about how television works, we present television fundamentals so that you don't have to be a genius to understand. We will explain television, from the instant the TV camera captures the image, to the moment it appears on your screen. To explain how television works, we follow our unique format that will uncomplicate some complex subjects. To understand how television works, simplified, we explain three things. What a television camera does. The three ways television signals are transmitted, and lastly, how the TV signal shows up on your screen. Often, the subjects we explain are more complicated and technical than the basics we cover, for example, explaining flat screens. We take liberties to achieve clarity and simplicity. However, by explaining how television works, using our unique formula, we deliver a solid working knowledge of the topic. Now, let's get into the science of TV. 79% of households worldwide have at least one television, influencing how we think and relate to each other. You watch television every day and don't think about how those images appear on the screen. However, you'll know precisely how before this video is over. The TVs of the 1940s and 1950s were smaller, heavier, and only showed images in black and white. Later in that decade, engineers developed a way to deliver images in color. Three things were needed for a TV broadcast to reach homes. First, a TV camera captured the image and converted it into a television signal. Second, a transmitter, like a TV station antenna, sent the signal to homes. Third, a TV to receive the signal and shoot an electron beam through the cathode ray tube to the picture screen. Now it's time to use our imagination. Think of a TV camera as a paper shredder. Every second it grabbed 24 to 30 still images, and shredded each into 525 separate horizontal strips. The TV station then sent a signal for each strip, to a giant TV antenna, which instantly forwarded each strip, one at a time, to picture tubes in homes. The picture tube then projected each of the 525 strips to the TV screen. The strips were projected so quickly, they appeared to be one solid image. Think about flipping through a child's flipbook. The images pass so quickly, they appear to be moving. Now imagine a flipbook with thousands of images. It would be like watching a movie. The same principle applies here. You might ask, how many still images did it take to create a 90-minute movie? Let's figure it out. Most films were, and are, shot at 24 to 30 frames, or images, per second. Therefore, every minute would require 60 times 30 images. Lastly, all that would be multiplied by the 90 minutes in the film. All told, it took 162,000 still shots to produce a 90-minute movie. TV cameras no longer create signals that way. Instead, they look at the entire image and direct it to microchips that convert what the camera sees into a TV signal. No longer are cameras limited to 525 lines. Most models today are capable of delivering 1080 lines or more. The result is greater clarity and color. Because of their size, today's LCD televisions are captivating. They create images differently than the older CRTs. Referring back to the paper shredder, remember how each image was transmitted as 525 individual strips? Imagine cutting those strips vertically as well. You end up with hundreds of little squares in each of the 1080 strips. While each of the earlier 525 strips could only be controlled as a single unit, each of the squares in the 1080 strips can be controlled individually. Introducing pixels. As you will see in a moment, it takes millions of pixels to create an image on an LCD screen. The word pixel is derived from the two words, picture and element. Each of these pixels contains a red, blue, and green light. To create a specific color, a filter mixes different amounts of those three colors and passes the result to the screen. Because each pixel can be manipulated individually, LCDs produce much sharper images than CRTs. Enormous, higher-resolution LCD TVs are in the spotlight. The current standard for HD TV is 2 million pixels per image. However, 4K LCDs are commonplace and boast of having 8 million pixels. 8K models are emerging, offering an unbelievable 33 million pixels. Theoretically, LCDs have no limit. Imagine home theaters engineered to project images onto all four walls of a room. It's not hard to imagine that eventually, we'll be doing a video on that. I said we would be done in a few minutes, and we did it. As mentioned earlier, the topics we explain are often more complicated and technical than the basics we cover. If you want to dig deeper into television technology, see the link below. If you enjoyed this video, click the like button and subscribe. Every new subscriber gives us incentive to keep explaining things to as many people as possible. Thanks for watching Explaining Difficult Stuff. By the way, there is no cure for curiosity.